Welcome to the HC Insider Podcast, a podcast dedicated to the commodities sector and the people within it. I'm your host, Paul Chapman. Today we're talking powering heavy industry. Heavy industry accounts for some 30% of global power consumption. Of that, a significant portion is taken by the mining industry, which is also crucial for energy transition. To date, much of the focus around achieving net zero targets has been on deploying new technologies, renewables, and exploring alternative fuels for heavy plant. There's little discussion, unlike in households, around efficiency and harnessing new technologies and capabilities to understand where electrons are flowing and how efficiently they're being used. That's the topic of today's discussion. Our guest is Manoli Yannaghas. Manoli is the MD and founder of Volt Vision, a digitized industrial power information company. He's had a long career as a mining executive, running mines big and small around the world, and as an entrepreneur. Manoli and his organization have been focusing on just this, how to tackle efficiency of power use in heavy industry. As always, you can support the show by leaving a positive review on the platform you're listening on, and I hope you enjoy the episode. Manoli, welcome to the show.
Thank you for having me.
So I am looking forward to this discussion. We are talking about the challenge and in some ways the opportunity that heavy industry around the world faces, particularly in the Western world where there's much more scrutiny and various tax and carbon regimes around their power usage. As we know from the last year, power prices have rocketed up, in the wake of the energy crisis. But there's also greater scrutiny as well from shareholders, stakeholders, and so on. So it is a challenging subject, but there is also opportunity framed within that around how organizations can better manage these costs. After a decade of not really, your energy costs were sort of last on your mind, over the last few years, given how low they were. But let's start, Manoli, if we can, at kind of what are the challenges that heavy industry faces when it comes to energy and in particular power consumption?
You said something there quite interesting. They haven't had to worry about their power costs. I think they always worry about their power costs, but what's happened over the last 10 years is that the price of commodities has been so high and the price of power has been so low that, as you say, they haven't really put that much thought into it. So I think when you combine that with the pressure that's coming from the finance industry to change the way they are using power, and that's being driven now by the new generation of investor who's no longer willing to put money into dirty industries and dirty companies who are not making an effort. This is Generation X, Generation Z, who are the new who are investing in pension funds, and pension funds now are pushing very hard to see companies change the way they generate power. Now, the pricing element is also obviously in pricing instability. No company wants to have pricing instability, but the mining industry in a way is used to this. I mean, they're used to this from a sales perspective. They don't usually operate in Spain. There are some, or the UK. They're operating in Africa and South America where they've got instability. So the pricing instability, I think, is stomachable within most of the large mining companies. They know how to handle it. The bigger problem, I think, is security, power security. How do you access the power? So if you're taking HFO or diesel, where's it coming from? And this is a perennial problem. How are you making sure that what you are ordering is going to arrive on time and is not going to, the supply chain is not going to be disturbed? Theft is a really big deal when you're dealing with something like diesel, which is cash for all intents and purposes. So it's easy to steal. When we were running mines in Madagascar, we lost 25% of our diesel. They were just sucking it out of the bottom of the vehicles and selling it. Jeez. So that's a big deal. And that's something that I think these companies are continually trying to move away from. And then grid. Most of the mines that we deal with are at the end of an already unstable grid. So they're not getting power security. They get a lot of cutouts, power cuts, lightning strikes, or they just get shut off when the grid can't cope any longer. So there is so many problems with power, and that have already been there and always been there. But now I think more than ever, there is a big pressure around moving away from dirty power.
Mm.
It's everywhere, certainly in the UK,
And we're
Australian-based
talking mining because I
companies.
know that's where Volt Vision is focused, but this applies to any large, heavy industry. And having just come back from South Africa, where rolling blackouts across Cape Town as a result of the grid not being able to cope because the nuke's
8
down.
hours a day.
Yeah, and
Yeah,
and the
8 hours a day.
and
Yeah.
the coal-fired power plant is having, by all accounts, rubble turning up at the gates, which then breaks the crushers, that then, shuts them down. It's a whole host of issues.
Well, there's your power security.
Yeah.
And to your point on mining, this is about every industrial application that is used worldwide. It could be cement, it could be, or I mean, the oil and gas industry have got a similar problem.
Mm.
So it's not just mining, but even though mining is a particular
And
problem.
so you've got this financial pressure, you've got stakeholder pressure, all of those things coming in, which are crucial when it comes to, especially in today's environment of high interest rates, how are you going to access lower interest rates? You've then got that very, as you say, all bets are off when you actually can't mine or you can't run your plant because there is no power. And existing, the on-site existing sources, diesel generators, as today, as we're recording this, you've got Zaporizhia nuclear power plant running on 12 backup diesel generators to cool, which is terrifying in and of itself. There's also, you mentioned in our discussions, there's a wave of new technologies coming at these organizations as well, right? So whereas there was a particular suite, pretty simple decisions about how you're going to have on-site power generation or whatever it was, the world is also changing as, both in terms of how people purchase power, but also the options to generate it locally as well.
Well, yeah, you're right. In the old days, it was diesel HFO generators or grid, and that's it. Now you can start talking about solar. You could talk about hydro. You could talk about, not many cases would you talk about wind. So you've got the suite of renewables, and you've got hydrogen. And these are all, I go to quite a few conferences and I listen carefully to what is going on in the marketplace. And I listen carefully to how these large companies have moved. And it took a bit of time. I mean, I think in all large companies, it takes a bit of time. Then now suddenly it's like a stampede. They've all made very big commitments to this net zero, in many cases by 2030. And that's just around the corner. That's going to be tough to make. So the pressure's really on from the top in order to clean up the act. So your options are, as you say, there are now more options. You can look at solar batteries. I think with solar, you have a problem with batteries, and lithium is not the static, it's my opinion, but lithium is too expensive for static battery on a large scale. So if you take a 20 megawatt mine, you're going to need 70 megawatts of solar, and you're going to need in the region of combined battery and solar $200 million investment in order for that to work 24/7. That's not going to work. It's too expensive. So the economics are not there. And we're working actually with the guys at Anglo down in South Africa, where they're doing hydrogen. So hydrogen's another area where everyone's very excited. Again, a lot of the big boys are putting a lot of money into this. Anglo have created a hydrogen battery truck, a hybrid truck, and that is going to be in production, I think, by the end of this year. Now, I heard a statistic the other day around that if you didn't use another truck in the mining industry, you'd save the equivalent amount of power as the country of Austria produces on a yearly basis. So it's a lot.
Mm.
So something like hydrogen and battery in this application is very interesting. But how do you generate the hydrogen? Because hydrogen needs a lot of power.
And also the timescales
So
to
you're
deliver
using
that,
diesel
right?
again?
Yeah, I mean, the other thing is this 2030, it's a really heavy lift to get to that point. It's interesting. When you look at this and you're in the boardrooms of all of the, all of these organizations, and having worked with them for a long time, is the main driver here that sort of around those commitments and it's kind of independent of the economics? Or is there actually sort of it's the twin forces and the economics now are really crucial as well? And how much does power, if we're talking about what are the big mining companies, I mean, how much is power how significant a cost is it globally for them?
If it doesn't make financial sense, they won't do it. There may be a slight divide with the majors, so like an Anglo American or a BHP. They may be willing to take a hit, but further down the size chain, it is cost. So they are interested in, of course, they're interested in cleaning up, but it has to be financially viable, and it has to be, the paybacks need to be sensible. And I see people putting it off for that reason.
We're going to move on to the other route organizations can take when you start factoring in cost, which is really, at the heart of this discussion, is actually the discussion around efficiency. And I've been having a couple of conversations leading up to a future episode with an individual whose basic premise is that energy transition is an impossible lift. Just ignore the money, but essentially just the infrastructure, the energetics of retooling a global economy is just not feasible within the next 20, 30 years, which is a pretty bleak picture, which begs the question of what then. But his focus is actually we should be spending all of our money enforcing and making all of our existing systems more efficient, the combustion engine more efficient, than putting money into quite speculative ventures, whether it's hydrogen or whatever it is. But that, I guess, comes into focus in this discussion as well, because there hasn't been much of an emphasis on actually efficient use of power in heavy industry for the most part for the last 10 years, right?
I think that's partially correct. The emphasis from that I am seeing is, let's quickly rush in and invest an awful lot of money into a large solar system, which will get you a 30% reduction in your CO2. It's almost a low-hanging fruit. It's just easy to do, especially if you're on the equator, which a lot of these guys are, or at least they're in nice parts of the world where there's lots of sunshine. So, but that's only 30%. How do you do the other 70, which is what you're talking about? And then, by the way, if you're going to go and make this investment, don't you want to make it onto what is already an extremely efficient operation? Because if you don't do that, then aren't you then over investing in your solar or whatever it is that you've invested in to generate power that's not needed? So this is with the conversations that we got into this business, our business at Volt Vision, because we started by designing solar parks for industrial applications. And every time we asked for a power profile, we couldn't get it because they didn't have it. So they didn't know, they were blind in terms of operationally with power. Now they all have very complex, well, not all. You have a lot of SCADA systems, and I'm sure most of your listeners will know what a SCADA system is in terms of it's an operational.
I don't. So
okay.
What is a power profile and what is a SCADA system?
Well, a power profile is how much power.
I'm allowed to ask the dumb question.
No, great. And I didn't know this either until a few years ago. A power profile is literally how much power they're using. Where's the power coming from? Where's the power being used? What's the point of use? And to be able to track that all the way through the system. And only when you do that, when you actually really understand where every kilowatt has come from and where it's going to and where it's leaving the system, can you understand how efficiently your system is being run. And then a SCADA system is effectively what is used to control the processing plant. So it is it requires a lot of data, but it's dealing with the production element. And it is a closed system. You can't access it because it's got control capability, which means that any data within it, you can't get it out. But it's focused towards how much am I producing and how can I produce more? That's what it's focused towards. It's not focused towards, well, where's my power come from and how can I improve my power? So these complex industrial applications, mining, oil and gas, whatever it might be, they're very focused on how do I make more rather than how do I make more for less.
And these SCADA systems sit, on your kind of whatever your on-site. I mean, I've been to a number of facilities and mini coal plants and all the rest of it. That sits on that on-site generation.
Well, you've seen them then. you've seen the guy sitting in front of all the screens. That's the SCADA. It's made by Siemens or ABB or one of the really big, and it's an impressive piece of kit. And they cost millions, but they're very focused on how do I make more.
And this sort of power profile, it's sort of the analogy is, if I were to actually understand where in my house power is being used, I'll discover kind of a long lost Alexa that's been on, in my daughter's bedroom for whatever, 10 years or something, and it's been using all the power in the house, right?
That's exactly what it is. You'll be able to know how often has the spin dryer been running for, how much power are your children using that you don't know. Everything. The toaster, how long's that been on for? You know everything. That's the point. And you can see it all on the press of a button. That's where you've got to get to. And if you're going to make the changes that you need, and you're already doing it with your heating, because most people have smart heating now. They know exactly what's going on with their heating, don't they? 10 years ago, what did you do?
But I live in Texas, so there's no such thing as a smart meter here. But yeah,
Yeah,
I guess
okay.
the point
That's a rabbit hole.
the point
Yeah.
is made. Do organizations, I mean, how much granularity do these large complex industrial plants have on that power profile? Is that information that's available?
It's there. The information is invariably there, but it's just not being picked up. So what is happening now, which is quite interesting, let's talk about Newmont as an example of a forward-thinking company when it comes to data. They are centrally monitoring every one of their assets, and when I say asset, I mean site, out of Denver. And all of the data is piped to a central control room where they have the most qualified people available within the company to be looking through every part of their business. And that includes power, includes other things too. And they're investing millions on systems and the ability to do that centralized monitoring. Interestingly, what they can't get is access to the data. So what they are looking for are ways in which you can get this data that's already within the system and unlock it, untether it, if you will, so that you can get it up onto the cloud. So they're doing it, but now they're trying to, and this is where the IoT gateways and the kind of the edge computing starts to come in. How do you get that data off site and up into the cloud so that they can utilize it, analyze it? So these big companies are doing it. The smaller companies, it costs a lot of money to do that. The smaller companies are looking at it, I'd say.
And then you've got the two elements of this. One is obviously then you can figure out which are sort of the very inefficient parts of your supply chain or value chain or production process, right? And does that machine really need to be on, etc. There's also, and this is kind of where I think we, globally from a household level through to a business level, right? The demand side, there's also kind of, it's fine if you're producing your own power, but again, it always has a cost if it comes back to diesel or whatever it might be, or you're using up unnecessary capacity on your solar panels. There's also kind of that demand side as well, I assume, when you can retool these plants to be able to use most power when power is effectively cheapest, at least if they're attached to the grid.
Time shifting. And again, you need to understand your system and how you're using so if you've got a very big crusher that has a bit of capacity left over in it, well, you can use some more of that capacity when the sun is shining, if you've got a solar park, for example, or if you're on a split tariff grid contract at night. But you need the data. You need to understand what's going on. It might also be that you can overproduce when it's cheaper, when the power is cheaper. That's a form of battery, and that's actually the most cost-effective form of battery. Or you may be over pumping the water that you might need over the course of the day. You do it at night. Whatever it is, that requires data. That absolutely is the most efficient way to run your business, and more people are looking to do that now. They're already into it, but what we find now is that when we can actually improve the visibility of how their operations are running, they can do more of it. So it's not like we're introducing a new concept. The concept's definitely there. People are already onto it. It's just a question of how can they maximize it.
The HC Insider podcast is brought to you by HC Group, a retained search, intelligence and advisory firm focused solely on the global energy and commodity sector. With 6 locations across Asia, Europe and the Americas and over 50 consultants. To find out more, go to our website, hcgroup.global. There, you can also sign up for our HC Insider content for more interviews and white papers on relevant trends and talent impacts in the commodities world.
I guess I don't really understand, and excuse my stupidity. What is the data, right? What is the data, and what's the challenge about getting it? Does every system have somewhere within it a track of where the electrons are going?
They do. So the data, it's quite simple. It's volts and amps. It's how much power are you using? Well, how's the power moving? So power is quite a tricky one. I'm not an electrical engineer. Most of my team are, and they describe it as a bit like water. So if you don't control it, it all kind of heads off in one direction, and it becomes rather inefficient and hard to control. On an existing, so we're very interested in high voltage and medium voltage. I'm not interested in your house. There's plenty of people who are able to get what is called low voltage data, whereas we're interested in high voltage. And what we mean by that is that's usually in this country, it's the transportation network. So, but also a lot of the big industrials use it, and it's very difficult to go and put sensors everywhere. So it's hard to go and put third-party sensors in a 33 kV substation. You just blow up. And apart from anything else, there'll be no warranties. There'll be no people don't want you in their substations. They get very nervous about it for the reason I just mentioned.
And if, by the way, they blow up, as per a previous episode, and these things are very expensive and take a long time to replace, right? So it's pretty catastrophic.
6 months, 6 months for a substation, and of course you've got the problem of So on all of on an industrial network, you have meters. But the meters in these instances are like mini computers, and they're collecting an awful lot of information. And actually, you can collect those, but very few people are centrally collecting this data. So it's there, but it's quite often it's not being collected. The second particular, or the area that we're really interested in, is what's called a relay, and a relay is effectively a fuse. It's what you've got in your plug, the little brown 13 amp thing. I don't know what they've got in America, but in the UK, and it's what effectively it monitors every millisecond a large amount of data, up to 2,000 data points. And that could be waveform, it could be harmonics, and this is noise. So power creates noise as well. So it's everything you could possibly want. And then every 7 seconds, 8 seconds, it determines there's no problem and it deletes the data. So what we do quite simply is we take that data, we trick the relay into giving it to us, and then we put it up into the cloud. So rather than it being deleted, we're getting it and we're putting it into the cloud. And once it's up in the cloud, we can do all sorts of things with it. And everything we do is really just to help our clients understand better what's happening on the ground. Whether they want to look at that in Denver or on the ground in Burkina Faso is totally up to them, but they have the choice.
And I mean, I'm assuming, it's not a sales pitch, I'm assuming though that's very powerful, right? In terms of, I guess, recognizing where these obvious inefficiencies are, where you're using a diesel generator for something that you could use something else for at a different time of day, or actually just turn off, or whatever it might be. On this sort of, the lens I come at this with is kind of this idea that new technologies have almost replaced making existing technologies more efficient. And I think that will change as prices, both of money and price of power, goes up. But what kind of effect can this have? And is it mainly changing behaviors, actions and processes, or is it actually switching out the old bit of technology that's consuming all the power and replacing it with a more modern, efficient, widget or whatever it might be?
Yeah. Well, I'm just going to touch on one thing, which is that if the company doesn't, as a structure from top to bottom, want to make the changes, then it's very difficult to achieve very much. It's got to come from the company that you're doing it with. And if that means that the guys on the ground don't want to see the change, then it's hard. That said, the opportunity that this gives you is twofold. The first is what I would call no capex. So you can effectively, with very little effort, change the way you're doing things. And that might be around power factor. It might be around how you interact with your grid supplier. And there are savings. There are always savings. And one of the things that it's boring. It's not a solar park. It's not 35%. It's 2% here, 1.5% there, 3% here. But these things add up. And so very quickly you can get yourself into a 9-10% saving across your static power network. And then there are what I would call the capex based improvements, and that could be around changing out a machine or a motor that is too big or too small, and you're running it inefficiently. And you can then very quickly work out what the IRR is on that and make the change. So there are, and that's what you can actually, I think the guys at Richards Bay, which is a mine in South Africa owned by Rio, did an audit 3 or 4 years ago. I think they brought ABB in actually to do it on what's called right sizing, where you go and look at every single motor, and they changed out 40% of their motors and saved just under 20% a year in power. So there's some big savings available here if you choose to get into it. That's what we do. And it's all about what we said at the beginning. How do you make your operations as efficient as possible? And how much are you willing to do that?
Yeah. Well, the backdrop to this as well is that the reality is that, okay, the energy transition is going to involve a hell of a lot of mining. And the reality is in 10 years, there's going to be more heavy industry than less. If we're all going to continue to have improving quality of lives on a global basis, and the march forwards in progress and growth, however you feel about that, right? So, and this is sort of the other flip side of the coin to installing decarbonisation power production. Ideally, we're using less of it because mining, the reality is that mining, all the materials that go into solar panels, into wind farms and so on, as we've covered on this podcast a lot, outside of the carbon intensive, it's also environmentally degrading, right? So, the emphasis here on efficiency for industry is going to be a crucial part of the solution going forwards. As we're all asked in our homes to be more efficient, quite rightly, those same things apply in heavy industry. So this is, I guess that's why I wanted to have this conversation and do the podcast on it, because it's interesting to me that we haven't yet really focused on efficiency in our 140 episodes, versus kind of the big sweeping, as you say, quite glamorous changes on that, of new technologies and so on that journey to lowering our carbon footprints.
It has to be both. It absolutely has to be both. And if you can't get in order, or get your house in order, if you will, there's no way that this net zero is going to be achieved. I mean, you talked about this heavy lift. I think 20 to 30 years is probably about right, but you're just never going to get there unless you can become as efficient as possible. And it's not just in power, it's in every aspect of how you behave. I mean, mining, in order to transition, we're going to need a lot more lithium, we're going to need a lot more of the rare earths. I mean, mining goes on. Yeah, mining is what is it, 5 to 8%? It's a pretty broad number of total global power consumption. It's a big number. And that's not even the industrial. I mean, if we go to industrial, I think there's a number out there around electrical motors in the industrial sector is about 30% of global power, but it's huge. It's really very big. So if we can't get that number down, then becoming sustainable, I don't see how that's possible, because we're just going to keep on generating large amounts of CO2. So
especially when those industries, by the way, are being are going to the developing world, right? As the long running sort of outsourcing of environmental impact. Again, as we've just covered, that's ultimately why China currently owns the battery supply chains around the world, is that Europe and the US in particular yielded it to them to avoid the environmental impact. And actually, in the course of that, China, quite smartly, Chinese businesses, decided that they'd own the value chain rather than just do the dirty bits. Again, and just as we discussed earlier, right, the further you get away from developed economies, the less stable the less likely you are to be using renewable supplies in some senses, and the less controls there are as well. Where is just so I guess to start wrapping up, where I'm fascinated by this. So is Volt Vision basically a technology, and where are you at in terms of the business growth, the cycle, and and penetration, I guess?
So I look at Volt Vision as as an end-to-end solution. It sounds very kind of grand, doesn't it? But what it is basically, I split it in two. First, the acquisition of the data. That's the first part of what we do. The acquisition of data from, as I mentioned, we use our own IoT that we extract the data through, and it's all about security and being able to get the data out in an efficient way. And the second is actually knowledge. So our team are electrical or instrumentation, and they're all industrial application. And it's then the ability to take data, because data is great, but I often talk to people and I ask them about their data, and they're like, yes, we've got a great big data lake. And I'm well, what are you doing with it? And they're, well, someone goes in every now and then and puts a spreadsheet together, and we all make our own charts. Well, actually, how do you get data into information, and information that you can use? Because what we're interested in is giving our clients access to something that they can use. They're busy guys, and they're in pretty tricky environments quite often, and they're working. What are they working? They work like 2 months on and a month off, or 3 months on, and they work 7 days a week. It's hard. So it's all about trying to make it easier for them. So it's this two-phased approach: get the data, and then make the data information. So that's what we are. We are, as far as clients, we work with Anglo. We're just starting our commercialization, so it's taken us a bit of time to develop everything. In terms of knowledge, we're also doing a lot of work with universities here in the UK to develop algorithms so that we can do, rather than just power quality, which is what I've talked about mainly here, but we also do condition monitoring, where, because we're able to take this data, we're able to see how these big machines, and we're talking 6 megawatt mill. I mean, it's a big mill. They're worth millions. How are they performing? And how can we see when things start to change? So, and that product's rolling out now with a number of our clients, but we are, I would say, early stage commercialization. We've digitized 6 of Endeavour Gold Mines assets in West Africa, and they're a very forward-thinking. I think they're mid-tier company. They're pretty big, 6 assets, but some of their assets are quite old. So we've been able to help them see exactly what's going on across all of their mines, which they couldn't do before. We've delivered them some quite significant savings, and we've helped them start to see pathways to operational efficiencies, which they know better than we do because they know their assets best. And the next step is to start moving into, we were just down at Indaba in Cape Town, like you. I don't know if you were at Indaba, but we also had 8-hour power cuts. And we met quite a few of the bigger mining companies who are very interested in the fact that we're able to access data. So it's what I mentioned earlier. How do you untether the data? So yeah, it's exciting for us in terms of, this is an interesting area. It's quite often I do get kind of pushed to one side whilst they bring the solar boys in, but people are beginning to realise that efficiency is a critical part of net zero.
Yeah. And as we've highlighted, I think it's sort of, when you step back, it's one that, as you say, is sort of somewhat neglected.
Well, it's not glamorous, is it?
No. But it will be. I mean, you were mentioning earlier on, 10% savings on these 20 megawatts is significant, especially if that means that your plant is up more time, right? I mean, the cascading impacts are quite powerful.
Yeah.
And
well, there is that as well.
And if people are interested in the business, how do they find you? Are there opportunities to invest, et cetera, et cetera?
Yeah. We are, well, you can find us at voltvision.live, and we are actually we're going to do a fundraise. We're doing one, we're about to start one actually, which is exciting because it's going to be so that I can accelerate us into not just different geographical locations, because at the moment we're really mainly focused on an African vertical. I want us to go into South America and to Asia, but also into the different industrial verticals. And we're actually developing some other technologies as well all around high voltage, so where we can effectively bypass the expensive digitization process. So, for example, substations in the UK and actually in the US are pretty old tech now, and they were built in the 50s. So how can you actually efficiently digitize them without having to replace large amounts of equipment? So we're developing stuff around that. And so that's what we're doing.
As we mentioned in the episode, Volt Vision are going through an investment round. If you want more information on Volt Vision, the business, or on the investment opportunity, please do email us at investment@hcgroup.global. Awesome. Well, kudos to you. Probably people can tell that. I just think this is however we end up coming to these solutions, using less energy is always probably a good thing, given the likely growth in energetic demand over the next 10 years, with or without net zero. Everything is we're producing more computers, etc., every day, and people are using more power. It's sort of an unsaid story of the next decade. But well, Manoli, it's been great fun chatting, having the discussion, and look forward to checking back in a couple of years and seeing the learning then and where you guys are.
Thank you, Paul. Thanks for having me.
Thank you for listening. If you enjoyed this episode and want to support the show, please give us a positive review on Apple Podcasts or Spotify. To find out more about HC Insider and HC Group, a search and advisory firm dedicated to the commodity markets, visit our website at www.hcgroup.global. There you can find out more about our services and our offices around the world. There you can also find more content, from interviews to insight pieces to more podcasts focused on the commodity value chains. Thanks again for listening.